Hello students, welcome to the classroom chemistry. Today in this video I have some questions 1, 2, 3 to explain the applications of formal charge. The first question is prove that ozone O3 is a molecule, and question 2 is prove that SiF6 is an atom. So now here question arises that how will you decide the given structure or a given formula is an ion or a molecule. So for this purpose, first of all you have to calculate the formal charge of each atom that are present in that structure or in that in that formula. So again, for this example, I am giving the example of the ozone. There are 3 atoms in ozone. These are the atoms, and each this oxygen. Suppose, for example, this oxygen is alpha, this one is beta, and this one is gamma. So again, alpha and beta oxygen are bonded with the double bond because the 2 electrons of the alpha oxygen and 2 electrons of the beta oxygen took part in the sharing. So they formed a double bond, and in beta and gamma oxygen, these electrons of the beta oxygen takes part in the bonding, and the electrons of the gamma electrons didn't take part in the bonding, so it has 6 electrons. So please, this oxygen and this oxygen is bonded with this single bond. So here it is, as I explained in my previous video, that it is sharing by the adjustment of the electrons, and I explained like that A gives it. Suppose A had 2 electrons and B has nothing, they short of electrons, so A gives 1 electron to B, and again they form a bond like this, and this is called as the coordinate bond, which is formed by the adjustment of the, so same form is here. So now we are going to calculate the formal charge of these alpha oxygen, beta oxygen and gamma oxygen. This is the formula. So the formal charge on O alpha is equal to, here, number of electrons in the valency shell before bonding or the free atom. So each oxygen has 6 electrons in its valency shell before bonding. So we will write here 6 and minus, this is minus. As I told you in my previous video that there are 2 types of electrons in this octet of this bonded oxygen. These are the electrons which didn't take part in the bonding, and these electrons, 4 electrons, are called as shared electrons. So here I have written the unbonded electrons. So how many? There are 4 unbonded electrons. You will write here 4 plus, and as I told you that the shared electrons are divided equally between both the bonded atom. So then I put here half to divide equally. The number of bonded electrons are 4. So you write here 4. This is the formal charge on alpha oxygen. So calculate 6 minus 4, the half 4. This will the value is 6. Then 6 minus 6 is equal to 0. So on alpha, you will find the formal charge on the alpha oxygen is 0. Now calculate the on beta. Now before bonding there are 6 electrons on the oxygen, and minus again the number of electrons we didn't take part on the beta, 2 electrons. You will write here 2, and the number of electrons that takes part in the bonding 4 plus 2 6. So then you will write here half into 6, that is 2 plus 3 means 5. So here 6 minus 5. So this oxygen has plus 1 electron. This oxygen has, the beta oxygen has plus 1 formal charge. Now calculate for the O gamma, 6 electrons in the outermost orbit, and here how many electrons are there which didn't take part in it? So you will find here 6 electrons. There are 6 electrons plus and 2 electrons which take part. These 2 electrons basically belongs to this beta oxygen, but as it takes part in the sharing, so this pair of electrons will be divided equally between both beta and gamma. So you write here half into 2, again 6 plus 7, 6 plus 7, 6 minus 7, that is minus 1. So these are the formal charge of each atom of the ozone, that is alpha. I have marked them alpha, beta and gamma. Now how will you decide whether ozone is a molecule and an ion? So here again you have to sum up the all charges of that are found on each atom on the structure. So the sum of the all charges is 0. It shows that O3 is a neutral. O3 is a neutral. So when a entity is neutral, group of atom is neutral, that is called molecule. That is the difference. And that ion, a charged atom or a group of atom is called ion. If any charge will be found here, then you will say that it is an ion. But here the sum of the formal charges of all atoms, alpha, beta, gamma, oxygen of the oxygen is 0. So this molecule is neutral. Neutral means it is an molecule. Hence it is proved that ozone, the O3 is a molecule. I think that you have understood. So here in this structure you will write here like this, because this oxygen, this beta oxygen contains here shows 1 positive and this gamma oxygen shows here 1 minus. So here in this way you can't show plus 1 plus and minus. This is the structure of ozone, and you can reversely is equal to write in this way double bow. So here 1 positive, this can be light. This is all about, I will explain you in the resonating structures. So this was about the ozone. Now I am going to explain you the second question, that is SiF6. SiF6, this is the structure. Please complete the electrons. All the fluorine atoms has 6 electrons in each fluorine. You will find 6 electrons in each fluorine. So here 6, and this bond is formed of with the sharing of 2 electrons in this way. Each fluorine has its complete octet, and this silicon has, there are 12 electrons. So again you have to prove that SiF6 is an ion. So you have to calculate the formal charge of each fluorine atom and silicon atom. So the FC of Si is equal to number of electrons in the valence shell before bonding or in the free atom. As the silicon number, the silicon is 14, so the electronic configuration of silicon will be 284. So you will write here 4 electrons minus again the number of unbonded. So unbonded electrons are 0. So you write here 0 plus bonded electrons. There are 6 bonds. and each bond is formed of by the sharing of 2 electrons. So naturally the number of electrons in the outermost of the silicon in the bonded, these are the shared pair of electrons, so half into 12, it is the, here you will get 4 minus 6, 4 minus 6, so this silicon has minus 2, and fluorine, the number of fluorine, there are the electrons present in the free atom of fluorine are 7, minus again each fluorine has 6 electrons. 6 electrons in the which didn't take part in the bonding each fluorine. So you get 7 plus 6 half the number of bonded electrons, the number of bond, each fluorine is bonded with a single bond, so there are 2 electrons which are called as bonded electrons. Now 6 plus 1, 6 plus 1, 7 minus 1 is equal to 0. In this way, each fluorine has 0 formal charge. All the 7 fluorines have the 0 formal charge. Now take the total. This is the minus 2. The sum of the formal charge of all atoms in the SiF6 is minus 2. Hence, SiF6. The SiF6 contains minus 2 formal charge. This is the SiF6 and this is SiF6. This is minus 2. So this SiF6 silicon hexafluoride is an ion. From the addition of the formula, you find the net formal charge on the SiF6 is minus 2. So it is an ion. Now come to the third question. Prove that SiF6 is a molecule. This is the structure of the molecule. Only the difference is here. Here it is Si silicon and here it is S sulfur. So how will you, the same procedure you will apply to find out the formal charge of Fc on sulfur. So sir, how many electrons are there in the outermost of the sulfur atom? As the number is 16, so 2, 8 and 6, you will find 6 electrons. So here the sulfur, there are 6 electrons, the right number of electrons in the valence shell of free atom of sulfur, there are 6 electrons, and minus again number of unbonded electrons. The sulfur, there are all these 6 electrons have taken part in the bonding, so there are 0. So you will write here the unbonded electrons in this sulfur, bonded sulfur is 0, and again you will write the half. This is half, and number of electrons in the bonded number of electrons, there are 6 bonds. So each bond is formed of 2 electrons. So we write here 12 electrons are that takes part in the bonding. So the bonded electron is, the number of bonded electron is 12. So again 6 minus 6 is equal to 0. This sulfur has 0 charge. Again find out the formal charge of each atom. This sulfur, each sulfur, there is this one is the octet of this sulfur. Each fluorine has 8 electrons in the bonded. So how will you? So fluorine. So first of all you have to write the number of electrons that are present in the outermost orbit of the fluorine, that are 7, and minus the number of electrons that didn't take part in the bonding, there are 6 atoms in each fluorine. You will find in each fluorine, you will write here 6 electron, and the number of bonded electron is 2. So you write here 1 half and 2. So in this way 7 minus 7, so each fluorine has the formal charge 0. So the net formal charge is 0. So that all the 7 fluorine atoms have 0 charge, and sulfur also has 0 charge. In this case silicon has minus 2 charge, and but here both the atom, these sulfur and all the other is, so here the net formal charge is 0. So in this way you can say that SiF6 sulfur hexafluoride is a molecule because it is a neutral. When the net of the total of the sum of the formal charge is 0, then the entity or the given structure or the given formula is neutral. If the group of atoms is neutral, then that is called a molecule. In this way, with the help of the formal charge, you can decide the given structure, whether the given structure is a molecule or an ion. So that's all for today. In the last, I expect your subscription, and I also say to you, please like it and share it to your friends so that they can find, those who also can find the benefit of these videos. That's all for today. Thank you very much.